Hello, this is Don with MecSoft Support. Today we're going to be discussing Visual3DPRINT 2017. And in this video, we're going to be doing Quick Start Guide number 1 in a series of 3. And in this guide, we're going to be taking a look at working with point clouds. Here is a list of the tasks to be completed. First, we're going to launch Visual3DPRINT and open the part file. Then we'll create a mesh from the point cloud. Then we'll auto-fix the mesh, refine and smooth the mesh. We'll analyze the mesh using curvature and reflection. We'll create and analyze slice curves from the mesh. We'll select a 3D printer and display its volume. We'll fit the mesh to the 3D printer and then check for errors. Then we'll organically grow a support structure. Finally, we'll export the mesh to an STL file and then generate a G-code file for the 3D printer. Okay, the first thing I want to do is talk a little bit about the VisualCAD Home ribbon bar. On this ribbon bar, after you install Visual3DPRINT, you should see the Visual3DPRINT main menu here. If you don't see that menu, move over to the left and select the Application Manager. And from here, make sure that the Visual3DPRINT checkbox is checked so that it loads whenever VisualCAD loads. Now, also from the Visual3DPRINT main menu, you have the Welcome option. Let's select that. This displays the Welcome dialog, and from here you can get additional resources about the product. For example, if you want to do this Quick Start Guide from a PDF document, you can select this option here and it'll display the Quick Start Guide PDF file. And in this video, we're going to be doing Chapter 1 on point clouds. Okay, also from the Visual3DPRINT main menu, you have the browser option. Now, this displays on the left and contains all of these commands specific to Visual3DPRINT. Now, you also have all of the VisualCAD commands up here that you can work with, but you have an additional browser with additional commands here just for 3D print. And we'll go over this browser briefly here. It's basically divided into 3 sections. You have the upper section, which contains a ribbon bar at the top and a data tree, which contains the objects that you're working on. It also has a toolbar in the middle and an information window at the bottom. Now, this window at the bottom will double for the command options dialog when you select a command. Now, for the menus, we have a series of tab menus at the top. We have a Create tab for creating various mesh objects for printing. You have a Model tab where you can work with those mesh objects to manipulate and edit your model. You have an Inspect and Modify tab where you can refine and edit your mesh and do some analysis on the mesh. Also, you have a Repair tab where you can diagnose problems with your mesh and other options that allows you to fix them. And then a 3D Print tab that has a section for build preparation for getting your model ready to print, and a 3D print section for selecting your printer, checking your model, make sure it's ready to print, and so forth. So let's get started and load the part file for this tutorial. From the VisualCAD main menu, select Open, and from the Visual3DPRINT Quick Start folder shown here, we're going to select a point cloud file in a CSV format. This is a comma delimited point cloud file. Now, you may also see point clouds in a TXT format, which is a text delimited file. If you don't see this particular CSV file, you can change the file type selector here and point it to point cloud files at this location, and you should see this file. Let's open it. Now, when you open a point cloud file initially, it's going to translate those point clouds into a mesh object or a point cloud object inside of VisualCAD. So for the translation options, we want to select comma delimiter, and then we want to check the box to create the point cloud. So here you can see we have a large point cloud object with multiple points, and if you look over here and select it, you can see that we have one point cloud, and we have over 12,000 points. And also the point cloud is listed up here in the data tree. Now, the first thing that we want to do is to create a mesh from this point cloud so that we can print it. And we have a command for that. Up here on the Create tab, select from point cloud, select your point cloud, right click, and now for all of these commands that we use in this particular video, I'm not going to call out the default value for each option, but you can in this video just pause the video and duplicate these parameters when you run this tutorial on your own, and you'll be able to follow along. So we're going to create a mesh from the point cloud. We're going to use these default parameters and pick create. So now what you see is in the data tree we have one point cloud and we have one mesh. Now we don't need the point cloud anymore, so we're going to turn this off by unchecking the box. If you don't see these boxes in your data tree, there's an icon down here on the toolbar that allows you to toggle hidden objects in the tree. If you toggle that on and off, you'll see that the check boxes appear, and we'll turn the point cloud off. So now we see, let's turn the grid off so we can see this a little bit better. We see that we have a mesh that has a lot of holes in it. Now you're going to find that this happens sometimes when you're working with point clouds. If the program can't blend all these points together in one particular mesh, you may have cracks and holes, and this is expected. But luckily in Visual 3D Print we have tools that we can use to work with these conditions. So the first thing we want to do, let's do a diagnose to see what kind of problems we have, and we know we got some, but let's just go ahead and do a inspect and modify, a repair tab, pick diagnose, select the mesh and right click and do the run checks. Now what you see is you can check these boxes to check for various conditions. The big thing that you want to check for is open edges. If you have open edges in your part, you won't be able to print it. So it has to be a closed volume, and you see here that we have over 1,200 open edges, so that we know we need to fix those. So let's go ahead and close that. Now we have commands on the repair tab to fix these automatically. We're going to use the auto fix command, and what that does is it'll stitch all these meshes together and it'll fill in these gaps. Let's go ahead and select that, pick the mesh, right click, and now we see that we have all those gaps closed. Although the mesh is not real pretty, it is closed. Let's do another diagnose just to make sure. See that we have 0 open edges. That's important. You could go ahead and 3D print this right now, but we want to clean it up a little bit further and also create a support structure. So let's go ahead and close this. Now also we have some commands on the inspect and modify tab that we can use to do remeshing, and we can smooth the mesh out. So let's go ahead and do a remesh and see if we can get this mesh to look a little bit better than it is. Let's select remesh, select the mesh, right click, and for the edge length we'll do a uniform remesh, and we'll set the edge length to 0.05, and we'll set the iterations to 4. Now this means that it's going to remesh the initial mesh, and then it's going to take those results and remesh it, and it's going to do that a total of 4 times. Okay, we're done. Now we can see that we have it's been completely remeshed, although because of the existence of the facets in the mesh, how they were not particularly smoothed out when we started, we see that we have all these little dimples and bumps in the mesh. Now we can also use a command to smooth these out, so let's use the smooth command. Select the mesh, right click, and for the vertex shift direction, we're going to allow the points in each vertex triangle of each mesh to move in both directions, both inward and out, so that it can, basically we're going to iron out the mesh and try to get rid of some of these abnormalities. So we're going to let them move in both directions. We're going to have 4 iterations, and we'll pick smooth. So now you can see it did a good job of smoothing it out. They're not as bad. Now we still have some dimples, and on yours, on your meshes, you can redo the smooth command over again and actually smooth it again and actually make it smoother. So let's do that. Select the mesh, right click, and we're going to do another 4 iterations on top of the first that we just did. So here you can see it made it that much smoother. It looks pretty good. Now in your models you can keep doing this and you can keep smoothing it out, and it'll get better and better and better as you keep smoothing it. For now, let's just work with this and we'll move on. Now, just to show you some of the analysis tools that you have in Visual 3D Print, while we're on the Inspect and Modify tab, you can also do what's called a reflection line analysis. Let's pick that. Select the mesh. And down here in the options dialog, what it's going to do is it's going to put a texture on the mesh, and you can choose to have that a horizontal texture or a vertical texture. We'll leave it at vertical, and we'll have a total of 10 lines, and we'll pick render. So what you see, what it does is it puts a rendering on the object, and it highlights the areas where you might have some little inconsistencies in the part. And we know we're going to have some little bit of raised areas. We're not too worried about those right now for this demonstration. So let's go ahead, while we have the model rendered, let's change over to the curvature analysis. And you have 4 curvature types. We're going to select the mean and pick Analyze. And what this does, this color codes your mesh, and it shows you color coded where the areas of extreme curvature are occurring. Now we know we have curvature in the beak, in the eye area, and around the neck and the tail, but it highlights some of these other little dimple areas on the part where we have some little curvatures. And as I said previously, you can continue to work this model and smooth it out even further. And also, let's go ahead and close out of this. You also have commands down here to remesh just certain areas. So if you want to pick the mesh, right click, you have these icons here on the toolbar that allows you to pick a subset of the mesh to remesh. Let's say you don't want to remesh all of it. Let's say you just want to remesh one little area. So you can set the radius for the selector. Let's say set that as 0.25. I know I'm going a little bit out of extending beyond the PDF version of this tutorial, but I think it's important just to take a look at this. If you set the radius to 0.25 and select the paint selector icon, you can go in and you can select areas on the mesh that you want to smooth out even further. So those areas are selected. So once they're selected, you can pick remesh, and it'll take those areas and make them remesh just those areas without affecting the rest of the mesh. Okay, let's move on now. Now another way that you can analyze your part is you can create slice curves that will simulate how the printer is going to slice this model up and print it. And you can look at those curves ahead of time. Let's do that. Let's go over to the model tab, and we have a command called slice. Let's pick it, select the mesh, right click, and for the distance between each slice, let's set it to 0.05 and pick slice. Now, what you see here in the data tree is we have a slice object that was created and added to the data tree. Now, to see this a little bit better, let's turn the mesh off, and we have the slice selected. Now, one thing you notice down here in the information window is it tells you about the slice. It analyzes the slice curves, and if you have any open curves in those slices, it'll tell you how many are open. We have no open curves, and we got a check mark, so that's good. That's what you want. So let's take a look at these curves, and we see that they look pretty good. They're pretty well formed, pretty smooth. They flow pretty well. Now, as you can see, we see some of these little anomalies on the back side that we saw during the analysis. You can barely see them when you look at along the edge, but they're not too bad. This is just a prototype, so we're gonna go with this. Okay, so these are our slice curves. Now, currently, when you initially create a slice, it's only a display object. If you want to export these to actual curve geometry, you can just select the slice, right click on it and pick export, and it'll create curve geometry for you. For now, we don't need the slice curves anymore, so we're just going to select it and hit the delete key, and we'll just remove those. Let's turn the mesh back on. Now we're getting close to being ready to 3D print this object. Let's go and select our printer. From the toolbar here at the bottom, it displays what printer you have selected, and also on the 3D print tab you have a command to select your printer. Let's go ahead and pick the printer, and it allows you to drop down and select from a list of printers. And for this particular demonstration, we're going to be using the ShopBot ABS2. That's because the ShopBot printer also accepts G-code as well as STL files. And we're going to be showing you how to use the G-code generator that's built into Visual 3D Printing as well. So we'll pick the ShopBot ABS2 as our printer. And we also have an icon here to turn the printer volume on and off. Let's maximize this. So here's the printer volume of the ShopBot ABS2, and we see that the volume is 7.5 by 7.5 by 5.5 inches. Now, currently, as you can see, our part is not inside the printer volume, so we have a command that we can move it into the volume for us. So pick the fit command up here on the 3D print tab, pick fit, select the mesh, right click, and allows you to align in the Z alignment and the XY alignment where you want to center it within your printer volume. So for now, we're going to put it right in the center of the Z and the X and Y and pick fit. So it's moved over into the box. Let's maximize this. Now, although it's inside the box, what you need to do, you need to double check and make sure that it's ready for printing, because if any part is physically outside of the box, obviously it's not going to get printed. So we have a command up here on the 3D print tab to check it. So pick the check command, pick the mesh, right click, and as you can see, we have a problem. Our printer volume is 7.5 by 7.5 by 5.5, but our mesh volume is larger than that, so we got an X there, so it fails that test. And obviously, since our mesh is larger, there's going to be meshes that are outside the printer volume, so that's failed also. Now the good thing is that all of our meshes are closed, so we have a check mark there. That's good. and has also a check for thin walls. We know we're going to have thin walls because we got a beak area that comes to a relative point, so that's acceptable. And we know we're going to have overhangs, so we know that's going to fail. Now we're going to generate a support structure for these overhangs, so we're not going to worry about the rest of those. But these up here, we need to fix those. Let's close this. Now, to see this a little bit clearer, let's go into the 4 viewport layout. And you can see clearly that our mesh is larger than the printer volume. It sticks out this way. It's too high in this way. So let's start by rolling this rubber duck model over on its side and see if we can fit it in the printer better that way. So let's go ahead and select the mesh up here in the ISO view. We'll select the mesh here, and down here on the status bar in VisualCAD, let's turn on the graphic manipulator. Select that, and you'll see the manipulator turns on, and we're going to rotate this about the x-axis. We'll select the rotate indicator on the manipulator, enter -90, press enter, and we see that the rubber duck was rolled over on its side. And let's turn the graphic manipulator off. Now we don't need that turned on. Now we look pretty good in the right view. Everything's fit in here pretty good, but we're still extending on the top view. So let's scale our mesh down a little bit. So let's select the mesh, and in VisualCAD, when you have an object selected, you see that you have the transform tab under the modify tab displays automatically. So let's select the transform tab, and we're going to do a scale, and the scale dialog displays, and we're going to do a uniform scaling, and we're going to enter a scale factor, say, of 85%, 0.85, and that's going to scale the entire mesh down. Pick OK. So now the mesh is scaled down. It's still outside the printer, but let's go ahead and do our fit command again. Fit, center and center. Okay, it looks pretty good. Let's do a check and make sure that we're ready. Say check, select the mesh, right click, and we got 3 check marks up here. Our volume's good. All meshes are inside the printer volume. That's good. All the meshes are closed. That's what we want. These two, we're not going to worry about this one, and we're going to create a support structure, so that one's okay also. Okay, let's go back over to the ISO view and then maximize that. So let's do a recap. We opened the point cloud file. We created a mesh from the point cloud. We analyzed the point cloud. We fixed it, and then we remeshed it, and then we smoothed it, and then we analyzed it. We did some slice curves to check those, and then we selected a printer, displayed the printer volume, and moved our part into the printer volume. So everything's all set to print. The only thing that we got left to do is we want to create a support structure underneath this part. Currently we have the part centered in the Z and in the X and the Y. So we have a cool command that allows you to create a support structure automatically for your parts. Go on the 3D Print tab, pick the support generation command, select your mesh, and you will see down here, now there's quite a few commands and options in the support generation command, and on the first tab, the parameters tab, I think what might help you understand what these parameters mean is let's pick the little help icon here and display the help for this command. Let's scroll down, and what this command does is it's going to generically create a support structure that goes from the base of your overhang on your part down to the printer bed, and it's going to generate this automatically. It's going to figure out how it's going to get from your mesh to the bed based on these parameters. Now if you look at this example here in this illustration, it gives you an indication of what these parameters mean. Now I'm not going to list each parameter. As I said, you can pause the video and you can duplicate these parameters in your part file when you go through the tutorial. But basically we'll just discuss them a little bit. We have an overhang angle, and what that is going to do is it's going to calculate where the overhang angles are on your part. So we're going to set it to 45 degrees. And then you can also set a minimum overhang height. In other words, how high can the overhang be? So we'll set that to 0.25. And then the max angle that the overhang can be that will generate a support structure will be 45 degrees. Let's display this help file again here. And then for the support diameter, that is the diameter of the support structure that's going to be created, created from the bed of your printer up to your part. And then we have a sampling distance. This is going to be the distance between each connector where it's going to connect on your overhang area. And we're going to set that to 0.25. And the connector diameter is the diameter of the point where it actually touches your mesh. So we're going to set that to 0.1. The connector height, which is the height of the connector between the overhang and the first joint in the structure, we're going to set that to 0.5. And the base diameter, base height, at the base of every one of these structures on the printer bed, it's going to create a base diameter and a base height as a foundation to hold this structure. So let's go ahead and close that. And also one thing I wanted to note on the base connectors on mesh, what that means is sometimes if the algorithm, when it determines the support structure, it may need, some of the base connectors may need to go through the part to get to the bed of the printer. Now you can minimize this. You can set this to minimize. You can allow them or you can disallow them. If you disallow them, then the algorithm will have to figure out another way to get around it, your mesh, in order to get to the printer bed. For now, we'll just pick the minimize option. Now we'll go to the support generation tab of the dialog, and you have two generation types. You have a tree type and a straight type. Let's do the tree type first, and we'll show you what that looks like, and then we'll pick generate. So now what you see here, let's turn the printer volume off so you can see a little bit better. Let's roll this up a little bit. The blue area is our overhang. That's our 45-degree angle. So it calculated all the overhang areas on your part, and it developed a support structure that started from your sampling points, your sampling distance that you entered on your support structure, and it grew a structure that goes from those points when it works its way down to the printer bed. And this is your base diameter and your base height. So that's really cool. Now if you want to see what the straight structure looks like, we can select that and generate, and you'll see that with that option it just goes straight down from each connector to the bed. Now this will use more printing material. I happen to like the tree structure because it looks good and it saves material, so let's pick that, pick generate. Now another neat feature on this dialog, again we're going a little bit outside the PDF version of this, but I just wanted to show you this while we're in here. You can add and remove support structures manually at this point. Let's say you thought it had too many supports here. You can go in and you can delete a support. You can just pick them and they'll be removed. So there's no more supports at those those sampling points. If you want to add supports, you can pick the add button and you can add those back. You can even add more. You can add anywhere you want. And when you feel comfortable with the supports and you like the way they look, we can go ahead and get additional details on the support structure. Go down to this tab and it's going to calculate the volume, the printer material volume that's required for your support structure. It's going to calculate the total length, linear length that's required to create these support structures. And both of those look good. So let's go down to the Create Mesh tab. Now here it gives you different options for actually creating the mesh. Currently it's just a display support structure. It doesn't actually exist right now. It's just in the display. So we have to create it based on the parameters that we've selected. Now you can choose to create a separate mesh object. In other words, there'll be another mesh in the data tree just for the support structure, or you can merge it with your part, and you can even create a separate mesh for each support tree. Now we're going to leave it at just to create a separate mesh. One of the benefits of that is later if you come back in and you say you think you want to redo the support structure, you don't like it, you can just delete that mesh and redo another support structure. Let's leave it create a separate mesh and let's create it. So here we have a second mesh was added to the data tree. That's our support structure. This is our part. And looks like we're ready to 3D print this part. Let's go up to the 3D print tab. Now you have, we can cancel this support structure command now. We don't need that. Now from the 3D print tab, you have different options that you can use to actually send this to the printer. You can export it to an STL file. You can select all the meshes, pick export, and you can export it to an STL file, a stereolithography file, or an SLA file, or an AMF file, which is an additive manufacturing file. You have 3 different file formats you can export to. For now, let's just select export it to an STL, and we'll pick save for now. So we got it saved as an STL file. Now we can also, since our ShopBot ABS2 printer supports G-code, let's go ahead and generate a G-code file and see what it looks like for this part. So we'll select the meshes, and we'll pick generate G-code, and we won't talk about all of these options on the G-code, but we'll just review them briefly. This defines your layer height of each layer. Let's set that to 0.003 say, and we're going to have one perimeter pass around the outside of the part, and we're going to retract only between levels. We're going to automatically calculate the volume. We're going to have 2 layers that are solid on the top and 2 layers that are solid on the bottom of our part. For the infill density, now this is a solid part, so the entire inside of this part is going to be infilled, and you may not want to fill it 100% and use all, more printing material. So we're going to leave it set at a density of 50%, and we're going to set a fill angle of 45 degrees, and I'll show you what that means in a second. And then we're going to set our top and bottom fill pattern to a crosshatch and our middle pattern to a crosshatch, and then we'll select the printer control parameter section, and this allows you to set the temperature for the extruder, the temperature for the bed, and your speeds of your extrusion. So let's go ahead and generate the G-code file. let's see, we got says a portion of this mesh is outside the printer volume. Do we want to continue? Well, let's take a look here. Let's go and do a check. And we see here that all of the meshes are closed, but we failed the volume check. So let's turn our volume on here and take a look here. Let's do a quad viewport layout. And as you can see, we've got one of our base connectors went past the mesh. So let's go in and fix that. We can go up in the mesh. Let's delete the mesh for the support structure. Go back in to generate another support structure. And let's leave this in a 3-4 quad port view layout so we can see it as we create this base support generation. We got the mesh selected. Pick support generation. And we'll pick generate. And we see that this one up here, let's go to the top view and let's regenerate that. Regenerate it. And we see that some of these are sticking out. So let's remove a couple of them. Let's delete this one and we'll delete that one. And let's see if this passes the inspection now. Let's go ahead and do that. Take a look at that. We'll go down to the create and we'll go ahead and create the mesh. So now we have the meshes created. Let's do another check, and that's a good reason why you should do a check on your part before you actually send it out to G-coding as well. So let's do a check. Select all the meshes, right click, and we see that we have 3 check marks, so that's good. Let's go back into the generate G-code command, select the meshes, right click, and we'll go ahead and generate. So you can see here it's kind of all meshed together, but let's see if we can't look at this a little bit cleaner. It generated all of the toolpaths for create the G-code for the printer. And what you can do, it's got a toolbar down here at the bottom where you can turn your toolpath on and off. Let's leave it turned on, and then we can look at it in levels. So select that. Now what this allows you to do, this allows you to scroll down and look at each level in the G-code of the print. So let's scroll on down here and let's look at this a little bit. So if you zoom in here, you see that we have our 1 perimeter pass at this level. We have a crosshatch pattern between levels. If we go from this level to the next, you'll see that the hatch pattern goes one way and then it goes the other. There's our crosshatch pattern. And let's zoom back out again and just go down on down and look at all of our part. Looks pretty good. Okay, looks pretty good. Let's go ahead and maximize that, and then we'll go ahead and generate the G-code file. We'll go ahead and pick the post command, and to create the actual G-code file, we'll call it rubberduck.nc. We have them there, but we'll go ahead and overwrite that. So it's calculating the G-code file for each of our levels in the print. And here is the G-code file displayed in Notepad. As you can see, it's got commands to start up the printer, disable the fans. It homes each of the axes. It sets the temperatures for the printer and goes to the G codes for each level in the print. Well, that's our quick start guide number 1, working with point clouds. If you got any further questions or you want some additional videos, you can visit us on the web at www.mecsoft.com.